CVP analysis, also known as marginal costing. What I have on the screen is the formula that we're going to come back to again and again. This is when we're starting to do our calculations, which we'll see later on. So first, we're asked to do a marginal costing statement. So our normal costing statement, okay, which is a profit and loss. So profit and loss costing, you'll have sales less cost, that equals gross profit. Then we'll take away from that expenses, and that gives us net profit. So that's profit and loss costing, are also known as financial costing. Okay, now marginal costing is slightly different. So marginal costing, we start with sales. So sales, then we have less variable cost. So the variable cost, if you think of the difference between variable and we have fixed cost, again, that we'll have to deal with here as well. So variable costs are the ingredients that go into the products that we make. So this is usually for businesses where they're making stuff, whereas profit and loss costing would usually be used by businesses who will buy and sell things. So variable costs would be the ingredients that go in. So the two main ingredients will be materials and maybe labor time. So that goes into every product we make. And then fixed costs are the general bills we need to pay just to keep our business ticking over. So that would be insurance, rent, wages, not like secretaries' wages, not the wages of people who are making goods, because that would be a variable cost. So when we take sales and a variable cost away, we end up with a thing called contribution. Take away our fixed costs, and that gives us profit. It's not called net profit or gross profit, it's just called profit. So that's a marginal costing statement. We're going to have to put some numbers into this here now. So sales is, in this question, taking the numbers from the question, 750. Variable cost is 560. So we're going to subtract those two numbers, and that gives us contribution of 190. Then we'll take our fixed costs. So our profit then is 190 minus 120, so 70,000. So it's just restating what you've already got in a slightly different format, but that's the marginal costing statement. So that's part A done, okay? Okay, next. We're asked to calculate the sales price per unit. So sales price for every unit that we sell, well, we're going to sell 750,000 euro worth. Okay, so that's the amount of money, okay, for selling 25,000. So if we divide 25,000 into the total sales money, that will give us the amount that we're going to get for every one unit they're going to sell. So it's sales price divided by units, or sales units. So it's 750 divided by 25,000 units. So 30 euros. So I'm just going to make sure we label this properly. So it's euros per unit. Okay. Otherwise we get confused. Are we talking about units? Are we talking euros? You need to just make sure that you label each. So the variable cost per unit, we're going to do something similar. So 560,000 our variable cost, and that's for 25,000 units. So we're going to divide 25,000 into it. So VC per unit is 560. Divided by 25,000 units. So 2240 euros again per unit. Move on to D. So calculate the contribution per unit. So contribution, we're told up here, is sales less variable costs. We'll do the same thing here. So sales less variable cost. So sales is 30. We've worked that out already up here. take away 2240, okay, so that will give us our contribution per unit. So it's 30 minus 2240, so €7.60, and it's euros. Just make sure we label that. Moving on to E. Calculate the break-even point in units, and this is where we start using this formula up here. So we're going to restate the formula and put the numbers that we've worked out into the formula so that we can work out what our quantity is. Now in this case, so the break-even point in units is what number of units do we have to sell to make no profit. So I'm going to put the numbers that I've worked out already in. So for S I have 30, that's my sales price. Take away 2240, so that's my variable cost. Multiply that by Q, so Q is the thing that I'm looking for in this case. Take away my fixed cost, which is 120, and that will give me a profit of 0. So break even point, I make no profit, no loss. So I'll restate this, so then I end up with 7.60 times Q. Now if I bring this 120,000 over the other side of the equal sign, it changes sign. So instead of being minus 120,000 becomes plus. So I'll have Q 7.6 Q equals plus 120. So the Q then is 120 divided by 7.60. So that number then in units, okay? Now we have to, you can't have a decimal point of a unit, so we need to round it to the nearest single unit. So in this case, the 0.47, 0.4 is less than 5, so the answer is 15789. So 15789. So that's the number of units that we need to sell to break even. If we sell less than that, we'll make a loss. If we sell more than that, we'll make a profit. So now it asks you for F, it asks you to work out what's the break even point in sales revenue. So how much money would we need to take into our till to be able to break even? So this is the number of units we have to sell. Now we need to turn that into the amount of money. So break even point in units, we'll multiply that by our sales price, and that will give us the break even point in money terms. So we have 15789 units multiplied by €30 sales price. So that means if we sell in euros terms, if we sell 473,670 euros, if that amount of money comes into the till, we make a profit. Oh, sorry, that we break even. If we sell more than that, we make a profit. If we sell less than that, we make a loss. Now we have to calculate the margin of safety in units. The margin of safety is basically how much of a cushion do we have in case we don't reach our target. And our target given the question is 25,000. So how much can we underachieve our target by before we start going into a loss-making situation? So margin of safety. So margin of safety is going to be the break-even point. Our forecast sales less our break-even point in units. So our forecast sales is 25,000 units. We take away the 15789 units. That's our break-even point, and that gives us our margin of safety. So we can undersell by 9,000 before we start going into a loss-making situation. So if we end up, it just gives us an idea of how much leeway we have in case we just don't reach our target. The last one then, H. What's the level of production units and sales revenue that give a profit of 95,000? So how many do we need to sell to get a profit of 95,000? So I'm going to go back to my formula here again, the S minus VC. So I'm going to use that same formula again. So what I might do is just copy it just so we have it and we can see the numbers that are going into it. So our S is 30. 2240 is our variable cost times Q, so we're looking for quantity, okay, minus 120 equals, and it says to get a profit of 95,000. When we used it before, it was get a profit of 0 because we're looking to try and calculate break even. So if I just do the maths on this, so 7.6 times Q. Bring the 120 over the other side and change the sign so it's added to 95. So we'll end up with 7.6 Q equals 205. So Q then, if we divide Q into both sides, so Q equals 205 divided by 7.6. And this is in units. Remember, we have to round it to the nearest single unit, so that means we'll add one on here, so 26,974. So 26,974. So that's in units terms, but it's asking us to work it out in units and sales revenue. So how much money would we take in if we sold this number of units? So we'll be multiplying this by our sales price, okay, which is 30 euro. So that's the amount of money that we would take in. I hope that makes sense to you.